Hey class, Mr. Hanji here. For today's lesson, we're going to be taking a look at section 4.2, which is going to deal with transversals and parallel lines. Now, for today's lesson, we have one learning goal, and our learning goal for today is that you will be able to identify an angle relationship formed by two parallel lines cut by a transversal, and use the properties of relationships to find angle measures. So today we're going to talk about four different angle pairs. They're going to be corresponding, same side interior, alternate exterior. And after we identify where those are, we're going to talk about what property results from those different relationships. So let's first get into talking about those different angle pairs. And the first one we're going to take a look at is corresponding. Now, before we jump into corresponding, we need to talk a little bit about terminology. So, first, a transversal is a line that intersects two coplanar lines at different points. In the figure, line T is a transversal, and the table is going to summarize the names of angle pairs formed by that transversal. So everything we're going to have today is going to result from two parallel lines. Lines P and Q are parallel, meaning they will never intersect. They will continue on in both directions and never touch. Now, the transversal is going to be the line that's going to cut through those parallel lines. So we're going to have two parallel lines cut by a transversal. And what we notice is that 8 different angles form from that relationship. So when I draw two parallel lines cut by a transversal, I have angles 1, 2, 3, 4, 5, 6, 7, and 8. And we're going to notice what we're first going to talk about is an angle pair, the different types, and then we're going to talk about what those result in. So our first angle pair is going to be corresponding angles. Now, corresponding angles lie on the same side of the transversal and on the same side of the intersecting lines, or the parallel lines. Okay, so I like to summarize this as they are on the same side of the transversal and then the same spot of the parallel lines. An example would be angles 1 and 5. So angles 1 and 5, they're on the same side of the transversal, so they're on the left side. And if you notice, in regards to angles 1 and 5, 1 and 5 are on the top part of their respective parallel lines. So, left side of the transversal on the top part of the parallel lines. So, that is corresponding angles. That is our first angle pair. Our second angle pair is going to deal with same side interior. Now, same side interior, the name tells us a lot about their location. And same side interior angles lie on the same side of the transversal and between the intersected lines. So they're on the same side of the transversal and in between the parallel lines. So I'm going to do that, or try to demonstrate that, by just focusing in between the parallel lines first. So that's going to be angles 4, 5, 6, and 3. And the one they highlight is angles 3 and 6. So if you notice, angles 3 and 6 are between the parallel lines, and they're on the same side of the transversal. So they're on the right side of the transversal, they're in between the parallel lines. That results in same side interior. Another set would be 4 and 5, but we'll talk about that a bit more later. So same side interior, in between the parallel lines, on the same side of the transversal. Alright, alternate interior angles are non-adjacent angles that lie on opposite sides of the transversal between the parallel lines. So if we go back to our diagram, again, we're going to be between the parallel lines. So we're going to ignore the top and the bottom parts of our diagram. So we're between the parallel lines. And this one talks about on opposite sides of the transversal. So that means we're on alternate sides. So 3 and 5 or 4 and 6. So whenever we talk about alternate interior, they alternate on sides of the transversal and they're in between or interior of the parallel lines. All right, and then our last angle relationship or angle pair is alternate exterior. So alternate exterior angles lie on the opposite sides of the transversal, hence the alternate, and outside the parallel lines. So if I were to just cover up or ignore the, if I can get it just right, the inside angles. Okay, so we're going outside of the parallel lines, so angles 1, 2, 8, and 7. And we're talking on alternate sides, so that would be angles 1 and 7, and then 2 and 8. So alternate exterior, opposite sides of the transversal, and then outside of the parallel lines. So 1 and 7, 2 and 8. All right, so that is our 4 different angle pairs for today that we're going to be utilizing. Next, we're going to talk about specifically corresponding angles, same side interior and alternate interior, and what those pairs, what relationship they have in terms of being congruent or adding up to something. So, with that said, that's going to be where we go into next before we get into our first example. We need to talk about those 3 properties. All right, so let's take a look at our first postulate, and it's going to deal with the same side interior angles postulate. Now, the same side interior angles postulate states this: if 2 parallel lines are cut by a transversal, like such, then the pairs of same side interior angles are supplementary. So what this supplementary part means is that they add up to 180 degrees. So whenever you have a pair of same side interior angles, they add up to be 180 degrees. So, with that said, recall that same side interior angles are on the same side of the transversal and in between the parallel lines. So if I were to go through and cover up the parallel lines or anything outside of the parallel lines, so this talks about the in between the parallel lines and then on the same side. Now, I need to go through, and I kind of partly covered it up, but it talks about indicate and list the pair of same side interior angles. So they're in between the parallel lines, so that would be 4, 5, 3, and 6. And then they need to be on the same side, so the same side of the transversal. So that would be angles 4 and 5, and then angles 3 and 6. So angles 4 and 5 is our first pair of same side interior, and then angles 3 and 6 is my second pair. So there are 2 sets of same side interior. And what we talked about with this postulate is that these add up to be 180. So angles 4 and 5 would equal 180, and 3 and 6 also equal 180. So they would add up, their measures result in 180. So for example, if I said that angle 3, let's say angle 3 is 150 degrees, that would mean angle 6 would be 30, because 150 plus 30 equals 180. So these 2 have to add up to be 180, and these 2 have to add up to be 180. And that is what the same side interior angles postulate is talking about. All right, so same side interior, add up to be 180. The next one we're going to talk about is alternate interior. So alternate interior angles theorem states if 2 parallel lines are cut by a transversal, then the pair of alternate interior angles have the same measure. So that means they are congruent, they are equal to each other. So when we talk about alternate interior, there we go. When we talk about alternate interior, they are the same measure. That means they are congruent to each other. So Recall, alternate interior angles are opposite sides of the transversal, and they are in between the parallel lines. So the first step is we're going to be in between the parallel lines, just like we were with same side interior. So we're in between the parallel lines, and they are on opposite sides of the transversal. So that means angles 4 and 6, and then 3 and 5. So when we have to indicate and list the pair of alternate interior angles, that's going to be angles 4 and 6, and then angles 3 and 5. So again, alternate interior, they are in between the parallel lines, and they're on opposite sides of the transversal. So alternate interior, alternate sides transversal, interior, in between parallel lines. All right, so we have successfully gone through and talked about same side interior and then also alternate interior. Remember, same side interior angles are supplementary, which means they add up to be 180. Alternate interior angles, they have the same measure, which means they are equal to each other. Anytime they talk about being the same measure, they're equal to each other, or the more fancy way of saying it would be that they are congruent. All right, so we have now talked about two, same side interior and alternate interior. While there's 4 angle pairs overall, we're going to talk about just 3 different theorems today, and our next theorem is going to be the corresponding angles theorem. So corresponding angles theorem is going to state the following. Let me just cover up example 1 for now. Corresponding angles theorem states if 2 parallel lines are cut by a transversal, then the pair of corresponding angles have the same measure. So that means that they are equal to each other or that they are congruent. So just like alternate interior, corresponding angles are also the same measure. So same side interior, they add up to be 180. Corresponding and alternate interior are equal to each other, so they are congruent. All right, recall, corresponding angles are the same side of the transversal, but they are not in between the parallel lines. They are on the same spot of the parallel lines. So, same side of the transversal. So if we focus on the left side, they are not in between, but they are on the same part of the parallel lines. So that would be angles 1 and 5, 4 and 8. So that's going to be our first 2 sets, is angles 1 and 5. Our second set is going to be angles 4 and 8. Again, because they are on the same side of the transversal, so they're on the left side, and they're on the same spot on the parallel lines. So 1 and 5 are above the parallel lines, just like 4 and 8 are above the parallel lines. So, well, yes, they are not necessarily in between the parallel lines. The better way to think of this would be that they're in the same spot of the parallel lines. So 1 and 5 are above, 4 and 8 are below the parallel lines. All right, now that is dealing with the left side. We also have the right side of the transversal to deal with. So that means we need to deal with angles 2 and 3, 6 and 7. So 2, 3, 6, and 7 are on the right side of the transversal, and angles 2 and 6 are on the top part of the parallel lines. So that means those two, angles 2 and 6, and then angles 3 and 7 are the other pair of corresponding, because they are on the right side of the transversal, and angles 2 and 6 are above the parallel lines, and then 3 and 7 are below. So again, corresponding, same side of the transversal, and let's really kind of change this to be more so on the same spot of the parallel line. So on the right side or above, right side or below, or if we deal with the left side, it's left side and above, the left side and below. Same side of the transversal, same spot on the parallel lines. Same side interior just has 2 pairs. Alternate interior has 2 pairs. There is 4 sets of corresponding angles, 1 and 5, 4 and 8, 2 and 6, and then 3 and 7. All right, so that is going through and talking about the 3 different theorems in terms of same side interior that add up to be 180. Alternate interior are congruent, and corresponding is also congruent as well. So with that said, example 1 is going to ask us to go through and identify the angle relationship for each example, and then use the properties to find the value of the angle in question. So if we look at example 1a, for example 1a, we're dealing with this angle right here, 96, and then the question mark angle right here. So what is the measure of that missing angle? Let's first identify the angle relationship. Both of these angles are in between the parallel lines. So they're in between the parallel lines, and if they're in between the parallel lines, like such, so if they're in between the parallel lines, that takes it to either same side interior or alternate interior. So the second question I have for you is, are they on the same side of the transversal or alternate sides of the transversal? Well, angle 96 degrees and the question mark are on opposite sides of the transversal. So that means we are dealing with alternate interior angles. So because we are dealing with alternate interior angles refers to the idea that the angles are congruent. So that means this missing angle is 96 degrees. And that is how we'll go through and do example 1. Now, this whole rest of the notes is just example 1. It's just a slew of problems where you go through and identify the angle relationship and then find the value of the missing angle. So if we look at part B, for part B, we are looking at 67 degrees and then this missing angle right here. So we have to ask ourselves, are they in between the parallel lines? They are not. So, because they are both not in between the parallel lines, that eliminates alternate interior and same side interior. And the 3 that we're going to use today, most of the time, is going to be alternate interior, same side interior, and corresponding. So these 2 angles are corresponding angles. Because out of the 3, the corresponding is the only one that is not, that both of them are not in between the parallel lines. So, the reason I know these are corresponding is because they are both on the right side of the transversal. So, 67 degrees and the question mark are on the right side, and they're both below the parallel lines. So, same side of the transversal, on the same spot of the parallel lines. That makes this corresponding, meaning this measure is 67 degrees. because corresponding angles are congruent. Alternate interior, corresponding, they are the same measure. All right, for C, if we look at the 61 degrees and this question mark right here, so these are going to be the two angles we look at. Both of them, if you notice, are in between the parallel lines, like such. So they're in between the parallel lines. So the second question you need to ask yourself is, are they on alternate sides of the transversal, or are they on the same side? Well, both of these angles are on the same side of the transversal, so that means we're dealing with same side interior. So, same side interior, they're in between the parallel lines, and they're on the same side of the transversal. Now, same side interior angles, they add up to be 180 degrees. So that means I need to know 61 plus what is going to equal 180. So to go through and solve these, when you have same side interior, anytime you have same side interior, they add up to be 180. So you're going to take 180 and subtract it by the angle that you know, which is 61 degrees. So we do 180 minus 61, and that tells me that this angle is 119 degrees. And that is how you go through and find the angle measure when you have same side interior angles. All you have to do is just take 180, subtract it by what you know. And that is how you get that measure. All right, so we have done an example of each of them, so we're just going to fly through the remaining ones just to give you more practice in recognizing them. Remember, alternate interior, in between the parallel lines on opposite sides of the transversal. Corresponding, they're on the same side of the transversal, and they're on the same spot of the parallel lines. Corresponding is going to be not in between the parallel lines. And then lastly for C, we know that these are same side interior because they're on the same side of the transversal and then in between the parallel lines. And then again to recap, alternate interior, they are congruent. Corresponding, they are congruent. Same side interior adds up to be 180 degrees. All right, let us move on. All right, next, part D, we have 89 degrees, and then our angle in question right here. So, what angle pair or angle relationship are these two angles? Well, they're both on the same side of the transversal, so that's either corresponding or same side interior. Are they both in between the parallel lines or on the same spot of the parallel lines? Well, they're not in between the parallel lines, so that means they are corresponding. So if we have corresponding angles, if we use the corresponding angles theorem, if I know this is 89 degrees, that means I know this is also 89 degrees. All right, next, let's take a look at E. So for E, we have 104 degrees, and then this question mark angle here. So, first question. They are both in between the parallel lines. So because they're both in between the parallel lines, we are either looking at alternate interior or same side interior. So the next question is, are they on the same side of the transversal or on alternate sides? Well, they're both on the same side of the transversal, So that means we have same side interior. And when we are dealing with same side interior angles, same side interior adds up to be 180 degrees. So that means I need to have 104 plus this angle to equal 180. So we're going to figure out by taking 180 and subtracting it by 104. So we do 180 minus 104, and we end up with 76 degrees for this angle right here. And again, I get 76 because I'm doing 180 minus 104 to get that 76 degrees. Anytime that you are saying they are same side interior, they have to add up to be 180. All right, for F, if we look at F, we are dealing with the 118 degrees and then this question mark angle here. Both of these angles are in between the parallel lines, so they're both in between them. So that eliminates it down to same side interior and alternate interior. The next question you have to ask yourself, are they on alternate sides of the transversal, or are they on the same side of the transversal? These two are on alternate sides, opposite sides. So that means we have alternate interior angles. And because we have alternate interior angles, the thing that we know about alternate interior angles is that they are congruent to each other. That means they are the same measure. So if this is 118 degrees, that means this needs to be 118 degrees as well. All right, by now I hope that you have a pretty good handle on identifying if they're alternate interior, corresponding, or same side interior, and knowing that corresponding and alternate interior are congruent, they're equal to each other, and that same side interior adds up to be 180 degrees. So I hope you have a good handle on that. Before I do sign off for the day, I do want to talk about these last two, or these last three, and they have a good reason why, and it's a good reference for future knowledge. All right, if we look at G, so for G, if you notice, we have 55 degrees and then the 17x plus 4. So I've involved x in this problem. While x is not necessarily going to pop up in your homework for today, it is going to pop up for tomorrow, and I just want to give you a pre-look at what you might see for future problems or tomorrow. Now, both of these angles are in between the parallel lines, and they're on opposite sides. So that means I have alternate interior angles. So because I have alternate interior angles, the thing that I know about the measure of these two angles is that they are congruent to each other. If they're congruent to each other, that means they are equal to each other. So that means I can set 55 equal to this 17x plus 4. So we can have it as 55 equals 17x plus 4. Now that I have that, we can just go through and solve. To solve, we're going to move the 4 over, so we're going to subtract it. So we're going to do 55 minus 4, and we get 51. So we have 51 equals 17x. And then all I have to do is divide this 17 over. So we're going to do 51 divided by 17. And I end up getting x to equal 3. So in this case, x equals 3. So if they were to ask you to not only use the angle relationships, but use those and their properties to go through and find the value of x, this is how you would do it. Identify the angle pair. Again, if it's alternate interior or corresponding, they are congruent to each other. If it's same side interior, they would add up to be 180 degrees. Okay, before we finish for today, I do want to take a look at H and I. If we look at H, the reason I'm talking about H and I is because for both of these, we are not talking about corresponding, alternate interior, or same side interior, yet I'm flashing back to the previous section, 4.1. If we look at 113 degrees in this missing angle here, what type of angles are these? They are vertical angles because I have two straight lines that cross and opposite angles are congruent. So anytime that you're dealing with opposite angles, they are congruent to each other and they are referred to as vertical angles. So they are vertical, and because they are vertical angles, that means that this is 113 degrees. Now, if I carry that same idea over to I, if this is 93 degrees, and I want to figure out the measure of this, these are opposite angles from two straight lines that cross. So that means these are vertical as well. And because they are vertical, we know they are congruent. So that means this measure is 93 degrees. And that is how we go through and find the measure of an angle and identifying the angle relationship when you have two parallel lines cut by a transversal. So, with that said, that is our lesson for section 4.2, dealing with transversals and parallel lines. We talked about 4 different angle pairs, and then we specifically used corresponding, alternate interior, and same side interior to go through and identify what angle pair they were, and then used those properties to go through and find the measure of the missing angle. So, with that said, that is all for our lesson today on section 4.2. If you have any questions, as always, just let me know next time you see me or via email. Be sure to use your completed notes as a reference while you work on the homework. And that is it for today. So thank you guys for listening, and I'll talk to you guys later.